Picture this. You're standing in the Arctic where temperatures plunge to -40 degrees, wind howls across the frozen tundra, and your survival depends on a house made entirely of ice. Sounds like a death trap, right? But here's the mind-blowing part. Inside that frozen dome, it can be a cozy 65 degrees warmer than outside. Yes, you heard that right. Ice keeping you warm. Let me explain how this ancient engineering marvel actually works, because the science behind it is absolutely fascinating. But before we dive into the thermal physics of frozen architecture, make sure you hit that subscribe button and ring the bell so you don't miss our upcoming video on other incredible survival shelters from around the world. Trust me, you won't want to miss it. So let's get straight to the question everyone's asking. How on earth does a structure made from the same material that keeps your drinks cold somehow keep humans warm in the deadliest climate on the planet? The answer lies in understanding three key principles: the properties of snow and ice, the brilliant design of the igloo itself, and the surprising amount of heat that your own body produces. Let's start with snow, because not all snow is created equal, and the Inuit people who perfected igloo construction over thousands of years knew this better than anyone. When you think of ice, you probably imagine something solid, dense, and incredibly cold to the touch. But the snow used to build igloos is actually filled with tiny air pockets. We're talking about snow that's been compacted just the right amount, where it's firm enough to cut into blocks but still retains about 50 to 95% air by volume. And here's where it gets interesting. Air is one of nature's best insulators. Think about it. Your winter coat doesn't keep you warm because of the fabric itself. It keeps you warm because it traps air in tiny pockets between the fibers, and that air acts as a barrier against the cold. Snow works exactly the same way. Each snow block used in igloo construction is essentially thousands of miniature air bubbles surrounded by ice crystals. This structure prevents heat from escaping through a process called conduction. Heat loves to move through solid materials, jumping from molecule to molecule, but when you interrupt that pathway with air pockets, you dramatically slow down heat loss. Now, the Inuit didn't just grab any random snow to build their igloos. They specifically looked for snow that had been deposited by a single storm and then wind-packed. This creates what's called sintered snow, where the snow crystals have bonded together but haven't completely lost their air content. Cut a block of this snow, and you've got yourself an insulating brick that would make modern engineers jealous. The thermal conductivity of this snow is incredibly low, somewhere between 1/10 and 1/3 that of solid ice. But the magic of the igloo isn't just in the material, it's in the design itself. And this is where thousands of years of Arctic survival wisdom really shines through. An igloo isn't just a dome. It's a carefully engineered structure that takes advantage of multiple principles of thermodynamics and physics. First, there's the shape. The dome is actually the most efficient structure for minimizing surface area relative to volume. What does that mean in practical terms? It means that for the amount of space inside the igloo, you have the least possible amount of exterior wall exposed to the freezing temperatures outside. Less surface area equals less heat loss. It's the same reason why animals curl up into balls when they're cold. You're minimizing your exposure to the elements. The dome shape also has incredible structural advantages. The curved walls distribute weight evenly across the entire structure, making it remarkably strong despite being made from blocks of compressed snow. Some igloos can support the weight of a person standing on top of them. This strength means you can build thicker walls without worrying about collapse, and thicker walls mean even better insulation. But here's where the design gets really clever. A properly constructed igloo has an entrance tunnel that's built below the level of the main living space. This isn't just for dramatic effect. Cold air is denser than warm air, so it naturally sinks. By having the entrance lower than the floor, any cold air that enters the igloo immediately drops down and flows out through the tunnel, while the warm air stays trapped in the upper dome where you're actually living. It's a natural cold air drain working 24/7 without any moving parts or electricity. Some larger igloos even have multiple levels inside with sleeping platforms elevated above the main floor. The Inuit knew that the warmest air would rise to the top of the dome, so they literally put their beds in the warmest spot available. Meanwhile, the coldest air in the structure stays at ground level, well away from where people are sleeping. Now let's talk about the heat source, because this is where things get really interesting. In the middle of the Arctic winter, where are you going to get heat? The answer might surprise you. Your own body. An average human being at rest produces about 100 watts of heat, roughly equivalent to a standard incandescent light bulb. That might not sound like much, but in a well-insulated small space, it's more than enough to create a comfortable temperature difference. When Inuit families lived in igloos, they might have several people inside, plus a small oil lamp called a kulik. This lamp, burning seal or whale oil, provided both light and additional heat. The combined heat from multiple people and a small flame, trapped inside an insulated dome with minimal surface area, could raise the interior temperature to around 0 degrees Celsius, or even slightly above freezing, while the outside temperature might be -40. You might be thinking, wait, 0 degrees Celsius? That's still freezing. That doesn't sound warm at all? But remember, we're talking about a 40-degree temperature difference. When you're comparing 0 degrees to -40 degrees, 0 starts to feel downright balmy. Plus, the Inuit wore insulated clothing and used fur blankets, so they weren't sitting around in t-shirts. The igloo's job wasn't to create room temperature. It was to provide a shelter that was survivable and vastly more comfortable than the lethal conditions outside. Here's something even more fascinating. The inside surface of an igloo can actually start to melt slightly from the heat inside. But instead of the whole thing collapsing into a puddle, something remarkable happens. The melted layer refreezes into a thin coating of solid ice, creating an inner shell that's even more impermeable to wind and air. This ice glaze actually improves the igloo's insulation by sealing any small gaps between the snow blocks. It's like the structure self-optimizes over time. The Inuit also sometimes added a thin window made from freshwater ice or seal intestine to let light in during the day. Even the window placement was strategic, usually facing away from prevailing winds to minimize heat loss. What's truly remarkable about all of this is that the igloo represents a perfect example of working with your environment rather than against it. The Inuit didn't have access to wood, stone, or conventional building materials in the Arctic, so they took the one resource they had in abundance, snow, and turned it into a sophisticated shelter that could mean the difference between life and death. Modern scientists and engineers study igloos to this day, looking at ways to apply these principles to everything from emergency shelters to energy-efficient building design. The igloo proves that sometimes the best solutions come from observing nature and understanding basic physics, not from high-tech materials or complex machinery. So the next time you see a drink sitting in a cooler full of ice, remember, that same material keeping your beverage cold could, with the right design and application, keep you alive in the harshest environment on Earth. Now here's a question for you. If you were stranded in a winter survival situation, would you try to build an igloo, or would you attempt a different type of shelter? Let me know in the comments below, and tell me what survival shelter you'd want us to cover next.